In this session, we'll be working on the problems in the Chapter 5 review, beginning with Problem 1. Classify the triangle at the right by its sides and by measuring its angles. Well, here we see that this side and this side are congruent because of these little hash marks here. So, two of the sides of the triangle are congruent. That makes it an isosceles triangle. Now, we need to classify it by its angles. What I've done here is I've positioned a protractor with the index over the rightmost vertex, and we're measuring this angle. So if we look out over here, that angle comes out to about 65 degrees, which makes that an acute angle. So now let's go ahead and measure this angle. Now I've repositioned the protractor so that the index is over the topmost vertex, and we're measuring this angle. And as you can see, the angle is again 65 degrees, which verifies one of the theorems that we talked about in the chapter, that of the base angles theorem. If two sides of a triangle are congruent, then the angles opposite are congruent. So we've verified that by measurement. Now let's go ahead and measure the vertex angle. And when we measure the vertex angle, we can see that it's just a little bit more than 50 degrees, which matches based on measurement error. So this triangle is an acute isosceles triangle. So that will be our answer. The triangle is an acute isosceles triangle. And now for problem 2. In problems 2 and 3, we're dealing with the exterior angle theorem. It says find the measure of the exterior angle. So the x is the exterior angle. The exterior angle theorem states that the measure of an exterior angle equals the sum of the measures of the two non-adjacent interior angles. So for problem 2, x equals 46 plus 86, and x equals 132. And now on to problem 3. So for problem 3, it's the same basic idea, we just have slightly more complicated expressions for the angles. But the exterior angle equals the sum of the two non-adjacent interior angles. So, for number 3, we have 9x plus 9 equals 45 plus 5x. Now, we'll subtract 5x from both sides. 4x plus 9 equals 45. We'll subtract 9 from both sides. 4x equals 36. And divide by 4. X equals 9. And now on to problem 4. In problem 4 and 5, we're looking for the measures of the acute angles in right triangles. This is the corollary to the triangle sum theorem, which states that the acute angles of a right triangle are complementary. So for problem 4, we will have 8x plus 7x equals 90. Since these angles are complementary, their sum is 90 degrees. So we go ahead and combine our like terms. 15x equals 90. And we divide by 15. X equals 6. So now that we have the measure of x, or the value of x, we're going to substitute that into each one of these angles. So for this angle, 7 times 6 is 42 degrees, and for this angle, 8 times 6 is 48 degrees. So those are the measures of our two acute angles. And now for problem 5. Problem 5 is the same idea with just a little bit more algebra involved. So these two angles add up to 90 degrees. So we have, for problem 5, 7x plus 6 plus 6x minus 7 equals 90. So let's go ahead and combine our like terms. 6 plus 7 is 13x. 6 minus 7 is negative 1 equals 90. We'll add the 1 to both sides. 13x equals 91. And we divide by 13. So x equals 7. So now we substitute this value of x into these expressions and we get our angle measures. 7 times 7, which is x, plus 6 equals 55. And then for this one, 6 times 7 minus 7 equals 35. So this angle is 55 and this angle is 35. And now on to problem 6. In this problem, we're trying to identify parts of congruent figures. So we're given that quadrilateral GHJK is congruent to LMNP. And we're supposed to identify all pairs of congruent corresponding parts. That's the first step. Now, the key to these types of problems is the congruent statement. Because of the fact that corresponding parts of congruent figures are congruent, we can use this congruent statement to identify the corresponding vertices. So vertex G corresponds to vertex L. So G and L. And we can see that those two angles are congruent. So we know that angle G is congruent to angle L. Same thing is true for H and M. So H and M correspond, and so angle H is congruent to angle M. J and N are congruent, and you can see J and N have the same number of these curved angle marks. These mean that these two angles are congruent. So angle J is congruent to angle N. That's an N. And K and P correspond. So angle K is congruent to angle P. Now the same thing works with side lengths. So you can see that GH corresponds to LM. So GH corresponds to LM. Notice the single hash mark here indicating that this is congruent to this. So we can say GH segment is congruent to LM. And we can continue this process with the other segments, HJ to MN. So HJ to MN, and we can say that segment HJ is congruent to segment MN, and JK to NP. So JK is congruent to NP. And then for the last one, we take the first and the last letters. So GK is congruent to LP. So GK is congruent to LP. Now the final part says write another congruent statement for the quadrilaterals. It doesn't really matter how you write these as long as you go in the same order. You can't randomly select vertices. So in this case we started with G and went clockwise. So if we wanted to, we could go counterclockwise. If we go counterclockwise in this figure, we must go counterclockwise in this one. So we could say G, K, J, H is congruent to L, P, N, M. So what we did was we started here, instead of going clockwise, we went counterclockwise. G, K, J, H, and L, P, N, M. And so now on to problem 7. So problem 7 is yet another example of the corollary to the triangle sum theorem. We have two right triangles here. We have angle S is congruent to angle T because of this little mark here. And they give us that angle S is 74, which means that angle T is 74 degrees because those two angles are congruent. So because this angle is 74 degrees, let's just put that in there so that we don't forget it. So 74 degrees. Now we can use the corollary to the triangle sum theorem to find the measure of this angle. Knowing that, this is problem 7, the measure of angle V plus 74 degrees equals 90 degrees. And so we just subtract 74 from 90. The measure of angle V equals 16. So that was a pretty straightforward problem, but you had to see that this angle and this angle were congruent and that these two angles are complementary. And now on to problem 8.